So just starting off here, our CNRC webpage is a decision support tool that can be used to prepare before an event, monitor during an event, and then evaluate after an event. Just going over a brief history of the CNRC webpage. Our first website we developed back in the late 1990s. It was a heavily text-oriented page, given the limited bandwidth of the internet back then. You can see an image on the right-hand side of what it looked like. The forecasts and the observations that we presented were all mainly text-based, very few graphics. But it did want to point out that it basically said we serve two purposes, and this basically continues to today. Just share hydrologic information with our users and partners, including all the NWS forecast offices within our area of responsibility. Then also provide the CNRC staff with a convenient method to monitor hydrologic and weather conditions. Like I said, so even at the very beginning of developing our webpage, this was our purpose for creating the webpage. Continuing on, back in about the mid 2000s, Rob Hartman, the HIC at the time, decided it would be best to have more control over our web development. So we actually developed some local servers at our office rather than housing our webpage at our regional office. And this gave us the ability to expand our web development greatly, having control over what we could display, how much data we could upload and such. So we started transitioning from more of a text-based web page to more graphics-oriented. At the time, though, the graphics were more static-based, graphical river forecast plots and static images of gridded, say, precipitation forecasts, and then kind of point data as well. From there, then, about the mid 2010s, from about 2010 up through the present, then we've kept developing our web page and expanding the number of data sets that we show. The image on the right is our current web page today. As I said, the ability to display numerous data sets, including forecasts, both short range and seasonal, a lot of real-time data sets, including precipitation and temperature. Then we've also included the ability to overlay different geographical outlays, including drainage basins, burn areas, counties, lakes, rivers, and such. As I know that sometimes people don't just like to see the graphics on the web page, they want to actually use the data that goes into what is on the web page. So we've provided abilities to download numerous data sets, including as PNG images, CSV files, XML files, and KML files, and then they can manipulate the data how they like. Also, just one thing I wanted to point out with our web page, even though we have several links underneath the home page, a large percentage of what a CNRC website user needs can be accessed from our homepage interactive map. As people understand, it can be frustrating to go to a web page and not really know where to go to find the data that they need. And so that was kind of in the back of our mind when we developed our front map interface, was to kind of have a one-stop shop where you don't have to dig through a web page to find the information that you're looking for. And so at this point also, I just want to say many thanks to Kyle Lerman. He's a CNRC hydrologist, been at our office since about 2009, I think, 2008 potentially. And he's been instrumental in making the CNRC webpage what it is today. Just his ideas and then the ability to code those ideas into a web page that we use today. So this is just a kind of a bigger screenshot of our web page. I'll go into a demo here in a little bit, but as you can see, the areas of the geographic overlays above the map that you can all add, the map interface below, and then on the right-hand side, the accordions of all the data that we provide on our front web interface. So as a decision support tool, in the preparation leading up to an event, typically from about 1 day to 1 week out, we have the ability to view and analyze the meteorological forecasts used in the daily hydrologic forecasts. These include precipitation. Our forecasters forecast down to 6-hour time scales out to 6 days. We also provide a freezing level forecast to the river models. That's to help determine the rain snow elevation. Those are instantaneous at 6 hours out 6 days, and then temperatures, which kind of helps with snow melt balance, which are also instantaneous 6-hour values 6 days out. On the right there, you can see just an example of a gridded QPF precipitation forecast with basins overlaid from an event back in 2017. Then also during an event, when monitoring takes place, we have many real-time data sets available for viewing, both point data and then quality controlled gridded data. Some of the sources for the real-time data, just to mention, the National Weather Service actually owns and maintains very few gauges. So we rely heavily on our federal and state partners like the USGS, the NRCS, California Department of Water Resources, and then along with county, cities, and other water agencies and research groups to provide the data that we provide on our webpage. So, and we're constantly adding new gauges. As the data focal point at our office, I'm always looking for new gauges and networks. And so this year I was excited that CW3E added several gauges across the state of California, and we work closely with the California Department of Water Resources to make sure that those gauges were included in our data sets and also into our quality control products. Types of gauges that are available: precipitation, we have over 2,200 gauges that we display on our webpage. Temperature is about 1,400 gauges. And then last, when it comes to snow water content and snow depth, we also provide the National Weather Service watches and warnings as an overlay. So you can see also several products like winter storm warnings and such on the interface. And then also for evaluating after an event, following an event, doing post-mortem, we provide a daily verification of our precipitation forecasts broken down into 24-hour periods. You can see on the right-hand side an example of what can be displayed on our webpage. This is from I think the one heavy precipitation event we had back in end of January of 2021. We also, for significant events, develop storm summaries, and I'll go through one of those also in just a little bit, but each write-up includes a general summary of events, an analysis of the precipitation data, both presented in gridded point data and also for KML downloads. There's also a weather synopsis, kind of the weather pattern that went into the heavy precipitation event, and then the hydrologic impacts of what occurred from that event. Unfortunately, with the drier conditions that we've been experiencing, the last one that we've published, they do take a few months to kind of gather all the information, and several of our meteorologists and hydrologists work on these. But the last one we did was the heavy precipitation event that lasted from January through February of 2017. So with that, I was going to quickly show the CRMC webpage and go through a couple of examples. Just a quick aside also that along with the map interface on the front page, you can also access a lot of these data sets in text format. You can see where it says recently issued CRMC text products. There's a pull down on the right-hand side. And from there, you can see the different types of data sets that we provide in text format. Anywhere from precipitation data, temperature, basin, and point forecast data, and all of our river forecast bulletins as well. So I'll skip the first couple links, or the kind of accordions here. They deal more with our hydrologic products that Brett Whiten's going to go through in one of the future sessions, and kind of go through some of more of the weather-related information that we provide. The first accordion here that I wanted to pull down is the observed precipitation. From here, you can see we provide point data that you can click at different time steps. Fortunately, there isn't a lot of precipitation out there right now, but you can see the amount of gauges that we collect through our forecast area. And then below that, you can get also precipitation point data that is both the raw data and then a subset of those that we actually quality control that is then gridded and used in our hydrologic forecasts. And the reason why we use the QSEED point data over radar estimates is just because of the poor quality of the radar estimated precipitation across the western US due to the terrain blocking and such. Below there is an area where you actually can see the gridded QPE then at different time scales. You can see this is the past 7 days of QPE across the CNRC area. Another thing that is nice, you can hover over the map area and actually get a readout and the elevation of the location of that grid cell. One other thing we provide for precipitation is monthly and actual water year back to the year 1996. The process has changed over time, but back to 1996 when we were doing quality control of monthly data, you can actually view now the gridded and point values for water years and such. So this would be the 2017 water year, kind of one of our last really heavy record-setting water years. And you can see also, you can get a grid readout of that information. And we also provide that same data in point values as well. So it's good for going back and looking at information. Next accordion that I wanted to pull down to show is the information about our quantitative precipitation forecasts. You can see that we do these forecasts, as I talked about, in 6-hourly time steps, but you can also view them in 24-hour gridded amounts and 72 gridded hour amounts, and then the entire 6-day QPF that our meteorologists issue every morning, and then during the winter season every morning or afternoon. Below that is observed temperatures, where we also have all the point data that we collect from across our area. And then below there, gridded information that we use as input into our hydrologic models. The observed data is either the IRMA or the RTMA data, depending on the timeliness of the information. Below there, we also provide forecast temperature data, both in gridded format, and then also we have these basin plots that I quickly wanted to show. This is very helpful during snowmelt time, where we're able to see the trend of the temperatures going forward and the past 5 days as well for the basin. The yellow here is the average temperature that's expected in the basin that time of year. The pink is the bounds of the records, and then the traces, the dark blue left of the black line here is the observed, and the green is the forecast for the basin. And we do that for actually the upper portion of the basin, lower portion of the basin in this instance. So it's actually the sub basins for each basin for those at elevation. Back to our interface, also offer freezing level information, both in forecast and observed. The observed is typically from the HER model, and the forecast, depending on the meteorologist's choice of which models that went into the input of their forecast, typically using the GFS or the ECMWF, using a top-down methodology of drilling down into the model and finding the highest freezing level. Flash flood guidance, water temperature data, and then I think Brett will touch on some of the climate and drought information we provide, the drought monitor and CPC's outlooks on our webpage. And then here's the QPF verification, where we actually have a database in here to show back to, I think about 2003, our forecasts. You can see then it'll show areas where green where it was over forecast, brown and red where it was under forecast. What also is nice here too is, other than the verification button, if you click on the button below that, you can actually see the QPE grid for that day, and then use the slider bar, go over to the QPF, and you can see what the QPF was and go back and forth from there. And the last thing I wanted to show then is storm summaries and what they actually look like. So here's the general synopsis of the event. This is from January and February of 2017. So just kind of a few paragraphs giving an overview of the event. Then there's a pretty detailed precipitation analysis. As I talked about, you can see the QPE as a gridded amount in a KML, or even point data on some of the storm summaries. Some graphics that we've collected that show different observed precipitation, normal precipitation, and how it departed from normal. Some analysis of the California Department of Water Resources 8.5 and 6 station index. And then below that, a weather synopsis, which goes through kind of more of the meteorology behind the event with some kind of weather graphics showing the weather pattern at the time. You can see for the 2017 event, kind of the different patterns in the atmosphere of what brought in the heavy precipitation. A lot of different plots, soundings. We've got snow level plots, radar imagery, satellite imagery, and different model reanalysis are basically showing the different levels of the atmosphere. Then below that, the different hydrologic impacts that were caused by the event. A good write-up there with a lot of media being the sources for information, and then some links to observed hydrographs. And that's about all I needed to show.